There's point moments, but so a moment. Does it talk about moments in there? Or do we need to just ignore that?
It talks about moment of inertia.
Oh yeah, moment of inertia. I don't know if he even says anything about moments in here though. Anyway, when you have a lever and you push on it with a force, it'll cause a torque, and that force is multiplied by this distance. So the longer your moment arm, the more force you're applying at that point. But it's not just a force, it's a torque. It applies a torque. So actually, with like a internal combustion engine, the crank running through the motor looks like this. And so it's got pistons attached to it. This would be like if it was flat, but they're not. They're obviously not like this. So anyway, this would be like a flat 5 or something. But the way it works,
Which you already heard of.
yeah, the Colorados and the Hummer H3 had 5 cylinders for a while.
Only other one I know of is TTRS from Audi.
Yeah,
Had 400 horse and an inline. It was actually inline.
Is it inline 5? Yeah. You actually don't do V5s because it'd be too much vibration.
Yeah.
But anyway,
And the Volvo.
Focus RS, the European spec one, had a 5-cylinder engine too with 300 horsepower. But anyway, the way it works is they rotate around this axis, right? So this arm on the crankshaft is being pushed on by the piston, and that creates the torque necessary to rotate the engine. So torque is made by taking a force and applying it along a lever that goes in a circle. Okay, so the longer this distance, we talked about this, the greater the torque, right? So if you come out here, you're applying more torque than if you push in the middle like that. Even if you're pushing with the same amount of force at both places. So the way you calculate torque is pretty simple. It's just torque is equal to the force times the radius. It's basically the lever arm. They use R just because it's, no matter what direction you're turning this, R will always be on the radial line. Okay. So, for example, instead of having it like that, say you had a bolt here and then a wrench, and you pushed on it like this. What's going to give more force, if you push on it like that or if you push on it straight?
If you push on it straight.
Yeah.
So you can't have a torque force that's not pushing in a circle then, right? So you can have a full.
Yeah, you can have a torque
Yeah.
that won't necessarily go all the way in a circle. Like any lever is applying a torque. So if I, like this, so you push on the doorknob, these door handles, me pushing on the outside of this applies a torque to the pieces in the middle of this. That's why when I push here, it's a lot harder to open the door and stuff. That's a torque. So that's the other thing, is it has to be perpendicular. And if you're not pushing perpendicular, then there's an angle here, and so they call that theta. Or it's actually not theta. It's RF sine of something. RF sine of phi.
Phi?
Phi, PHI.
Oh.
So this would be force times R sine of phi. Okay.
What is 3 lines in equal sign mean?
That's a definition. So it's always equal to that. So you don't need to worry about it too much. That's just when they introduce new things it's set in stone. That's always how it's going to be. They put 3 equal signs. So it's like a defined as. So torque is defined as the force times the radial arm times the sine of the angle between them. So let's look at this. So if you've got a torque, say this is 5 meters, and you apply 5 newtons, how much torque are you applying to this point?
25.
So this would be 25 Newton meters. What if you had the same 5 meters and you pushed on it like this, 5 newtons, at an angle of 60 degrees?
We need to break it into a vertical component.
Okay, so that would be this.
Yeah.
How long is that?
That would be sine.
Yeah.
Yeah, 5 sine 16 times 5.
Okay, that's Newton meters. What if you have this 5 meters and you push on it this way? So you're pushing it on the end of it.
I'm not sure. I think that would be 0.
Right. So you're not putting any torque on it here, you're just pushing on it. And that's because, what's the angle between the radius arm and the force?
0.
0 degrees.
0.
So you'd have 5 times 5 sine of 0. Sine of 0 is 0. Okay. So how do you determine, let's say we turn that a little bit. We've got this way. It's 5 meters. And we push on it.
So phi is just kind of a different kind of theta, right?
Yeah, it's
kind
just
of a
another
second
Greek
reference
letter that we usually use as an angle. So usually you'll see for angles, you'll see theta.
So it's not strictly for torque. It doesn't apply just to torque.
No, but they use it in the torque equation for no particular reason. You have phi, and then you also see alpha, beta, and gamma pretty frequently. Those are usually representing angles.